Hey everyone, in this video we're going to continue talking about the real zeros of polynomial functions. Last time we used the remainder and factor theorems, and so this time we're going to talk about Descartes' Rule of Signs, and that's going to help us find the number of positive or negative real zeros of a function. So let's begin by stating this theorem that the number of real zeros of a polynomial function can't be more than its degree. So if you have a polynomial of degree 3, then at most you have 3 real zeros. If your polynomial is degree 10, then you have at most 10 real zeros, or another word is real roots of the function. Alright, so here's Descartes' Rule of Signs. It's a little bit wordy, but I'll re-explain it for you so that it makes sense. So if you have your function f, and then you have two possibilities. So the number of positive real zeros of your function either equals the number of variations in the sign of the non-zero coefficients of your function, or equals less than that number by an even integer, and then the number of negative real zeros either equals the number of variations in the sign of the non-zero coefficients of f of negative x, or less than that number by an even integer. Let me rephrase this because this is very wordy. Pretty much what it says is if you have a polynomial function and you want to know what are the numbers that I can plug in that make this equal 0. Those are what we call real zeros. Well, the positive numbers that you plug in, the positive real zeros, then you can figure out how many there are by looking at the sign changes. So number of variations of the sign, it just means sign changes. So signs change from positive to negative to positive to negative and so on, or vice versa. It's that amount or less than that amount by subtracting 2. So let's say I count my sign changes. If I have a polynomial function where I have something like negative something, plus something, minus, plus, so it changes signs once, and then it goes again twice, 3 times, 4 times. Then I have 4 sign changes, and then I would say, okay, so I have 4 positive real zeros, or take away an even integer, or 2 positive real zeros, or take away an even integer, or 0 positive real zeros. And the same thing is true for negative real zeros. So you have negative real zeros that you plug into your function, negative numbers, and that's if you plug in negative x into your function, simplify that, and then count the sign changes. So all you do for Descartes' Rule of Signs is you count the sign changes, how many times you change from positive to negative or vice versa, and then that's the number of real zeros that you have, positive or negative, or that amount minus even numbers. You start subtracting 2. Okay, so let's make that make sense by doing an example. So use Descartes' Rule of Signs to talk about how many possible real zeros there are of this polynomial function. So the first thing to notice is that it's degree 6. So this function has at most 6 real zeros. There's 6 possible numbers that when I plug them into my function, into all of these spots for x, that the answer is 0. Okay, so there's 6 possible numbers. And Descartes' Rule of Signs is going to help me figure out how many of those numbers are positive or negative. Okay, so let's count the sign changes. Let me clean this up just a little bit for us. So right now we're focused on the positive numbers because we're looking at just regular f of x. So notice this is positive 2 to negative 3. So this is 1 sign change. Then from negative to positive, that's 2 sign changes. Positive to positive is not changing. Positive to negative is changing, so that's 3. So there's 3 times that the signs change in this function. And so because there's 3 sign changes, then that means that there's 3, or take away 2. You keep taking away 2 till you can't anymore. 3 or 1 positive numbers that plug into our function to equal 0. And we call those positive real zeros. Okay? So that's it for our positive real zeros. There's either 3 of them or 1 of them. And then for the negative numbers, you actually have to plug in negative x. So if you want to look for your negative real zeros, plug in negative x into your function and simplify. So if you plugged in negative x and you simplified, negative x to the 6th power is positive, so that's why this is still positive 2x to the 6th. Negative x to the 4th power is positive, so then times negative 3 is negative. Negative x squared was positive x squared, so that's positive x. And then positive 5 times negative x was going to be negative 5x. Okay, so now we can count the sign changes. Positive 2 to negative 3 is one sign change. Negative 3 to positive x squared is another sign change. And then right here we change signs again from positive to negative 5. And then this one does not change, so that's 0. So we have 3 sign changes. And so 3 or, take away 2, 1 negative real zeros. So we have 3 or 1 negative numbers that when we plug them into our function, we're going to get 0 as the answer, and we call those negative real zeros. Okay, so this means that the graph of this function has either 3 positive x-intercepts or 1, and 3 negative x-intercepts or 1. Okay, so Descartes' Rule of Signs just helps us start to narrow down how many real zeros that we have for our function and what they look like, if they're positive numbers or negative numbers. So in the very next video, we'll start to narrow this down even further by using what's called the rational zeros list. So I'll see you soon in that one.